Now if I take the inverse tangent of the tangent of a value, that is equal to that value if that value is in the range of our arctangent function. So, for example, if I take the inverse tangent of the tangent of pi over 4, that is inside the range of our tangent function, so that's just pi over 4. If I take the inverse tangent of the tangent of, say 3 pi over 4, now 3 pi over 4 is not in the range of our inverse tangent function. So this is not just 3 pi over 4. If you're doing something like this and this value is outside the range of the inverse function, you need to use reference angles again. So the tangent of 3 pi over 4 is in, well, 3 pi over 4 is in quadrant 2, your tangent is negative. The inverse tangent only gives you values in quadrants 1 and 4. Okay? And those values are negative in quadrant 4. So even though 3 pi over 4 is a quadrant 2 angle, where tan is negative, the inverse tangent function only spits out values in quadrants 1 and 4. So the inverse tangent of that value then is, we're taking the inverse tangent of a negative, which means that we're going to wind up in quadrant 4. So we're starting out with the quadrant 2 angle, we're going to wind up with a quadrant 4 angle. This 3 pi over 4 is a pi over 4 reference angle, so that means we're going to wind up with our pi over 4 reference angle in quadrant 4, which is minus pi over 4. Okay. You could also evaluate this and then evaluate the arctangent. But we should also know how it translates from quadrant to quadrant, because I could do something like, I could say, what is the inverse tangent of the tangent of 8 pi over 9? Now 8 pi over 9 isn't an angle that we know trig functions of, but we could still evaluate this without our calculator, because we know that we could figure out that 8 pi over 9 is in quadrant 2. Tangent is negative in quadrant 2, so when we take the inverse tangent of a negative value, we'll get back a quadrant 4 angle that has the same reference angle as this. 8 pi over 9 is pi over 9 less than pi, so it's right here, and this reference angle is pi over 9. So this is going to spit back out minus pi over 9, because that is the pi over 9 angle in quadrant 4. So taking an inverse, you can wind up using reference angles. Now, inverse tangent of the tangent of y is equal to y if y is in the range of tangent. The same is true of our sine and cosine functions. Inverse sine of the sine of y equal to y. Inverse cosine of the cosine of y is true if y is in the range of inverse sine, and this is true if y is in the range of inverse cosine. Now here I'm just going to run through the reasoning of a few examples of what I just talked about. Finding the inverse sine of the sine of an angle that is not, just finding the inverse sine of the sine of an angle, inverse cosine of a cosine, inverse tangent of a tangent. Right? Keeping in mind sine and tangent, inverse sine and inverse tangent spit out values in quadrants 1 and 4, and inverse cosine spits out values in quadrants 1 and 2. So, arcsine of sine of pi over 3, well, pi over 3 is in the range of arcsine, so this is just pi over 3. You don't need to worry about it. Inverse cosine of the cosine of 7 pi over 6. Well, 7 pi over 6 is not in quadrant 1 or 2. 7 pi over 6 is in quadrant 3. And in quadrant 3, cosine is negative. Cosine is also negative in quadrant 2, so we're going to get back a quadrant 2 angle. 7 pi over 6, the reference angle, is pi over 6. because that 7 pi over 6 is pi plus pi over 6. So in quadrant 2, we'd be taking pi minus pi over 6, so we get back that second quadrant reference angle, 5 pi over 6. 3 pi over 4 is in quadrant 2. In quadrant 2, tangent is negative. Tangent is also negative in quadrant 4, and quadrant 4 is where arctangent gives you values. So we want the pi over 4 reference angle in quadrant 4, which is minus pi over 4. Minus pi over 6 is in quadrant 4. In quadrant 4, cosine is positive. Cosine is also positive in quadrant 1. That's where the inverse cosine gives you values. So this becomes the quadrant 1 angle, pi over 6. 11 pi over 10 is in quadrant 3. Sine is negative in quadrant 3. Inverse sine of negative value is a quadrant 4 angle. So we want the quadrant 4 reference angle for 11 pi over 10. Reference angle for 11 pi over 10 is pi over 10. So this is minus pi over 10. Inverse tangent of the tangent of 3 pi over 2. Well, tangent of 3 pi over 2 does not exist. It is undefined. So the inverse tangent of an undefined value does not exist. I threw that last one in there to remind you that there are values where tangent is undefined, so you can't always evaluate that. Even if even if you could get back an angle that has the same tangent, it doesn't necessarily work out when that tangent value is undefined. We can also kind of mix and match our functions by drawing a triangle. If I want to take the sine of the arc cosine of 2/5, I don't actually need to figure out what this angle is to evaluate the sine. This is just saying, this is the same thing as saying that the cosine of some angle is 2/5, so we can draw a triangle just like we did before. We draw a triangle, this is theta, and the cosine of theta is 2/5. Cosine is adjacent over hypotenuse. By Pythagorean theorem, this side is the square root of 25 minus 4, which is root 21. So the sine of the arc cosine of 2/5 is root 21 over 5. Right? Pretty straightforward. If I want to take the tangent of the inverse sine of, I don't know, say 4 over 7. Again, we can draw a triangle. The sine is 4 over 7. This is our angle. Sine is opposite over hypotenuse, and this side is square root of 49 minus 16, which is 53, which I don't think reduces. And then the tangent of that angle would be opposite over adjacent, which we rationalize to 4 root 53 over 53. So we can take those composites of our trig functions just by drawing a triangle. It gets a little bit trickier when you're in when you're in a different quadrant. So you have to keep in mind what quadrant you're in. Let's say I want to take the cosine of the inverse tangent of minus 1/2. Okay. We can forget about the sign of the SIGN sign here, the minus there, for a second, and just draw our triangle. The tangent of our angle, 1 over 2, and by Pythagorean theorem, this is square root of 2 squared plus 1 squared. It's root 5. So cosine of that angle is 2 over root 5. Right? Now let's worry about the negative. Arctangent of a negative will get you a value in quadrant 4. In quadrant 4, the cosine function is positive, so we keep this positive. Let's just do one more example like that. We can take, if I want to take the cosine of the inverse sine of, I don't know, say minus 2/3. I can draw my triangle. There's my angle, sine. It's opposite over hypotenuse is 2 over 3. 3 squared is 9, minus 2 squared is root 5. The other side is root 5. Cosine of this angle is root 5 over 3. Now I think about my positive or negative. Inverse sine of a negative gives me an angle in quadrant 4, and cosine is negative in quadrant 4, so this is negative root 5 over 3. We can also take these compositions by drawing a triangle even if we don't have numerical values that were inside our function. This means that the tangent of our angle is x over 4, so opposite over hypotenuse, or over adjacent is x over 4. And by Pythagorean theorem, we can then figure out that this side is the square root of 4 squared plus x squared. So that side is the square root of 16 plus x squared. Cosine of that angle is 4 over root 16 plus x squared. So even though we don't have a value here, we can still find an algebraic expression for the cosine of the arctangent of x over 4. Any variable expression, so you don't really know if it's going to be rational or irrational. So if you have a variable in there, you don't need to worry about rationalizing your denominator. Just another example, I want to take the sine of, oh wait, that doesn't work, because, why doesn't this work? Because x plus 1 over x is going to be greater than 1. You can't take the arc cosine of something greater than 1. We'll make this x over x plus 1. So, we can draw a triangle. Cosine is x over x plus 1. Then, this side over here is x plus 1, square root of x plus 1 squared, which is x squared plus 2x plus 1, minus x squared. So, that's the square root of 2x plus 1. So then the sine of that angle is just opposite, which is root 2x plus 1, over hypotenuse, x plus 1. So again, we can evaluate this algebraically even without having numerical values for our functions.